Hello and welcome to this BricsCAD Digital Summit session for BricsCAD Mechanical. My name is Fredrik Gundersen. I act as a product owner within BricsCAD, and today I will be taking you through the session about integrating BIM and mechanical data together through designs in context of buildings. So let us not waste any time and get started. Designs in context of buildings can involve aspects from several industry areas, such as mechanical and electrical equipment, and of course the building to house it all. In the end, it is important to gain a full view of the requirements of each of these areas of the project. Therefore, having a unified view of the equipment needed is very valuable, be that the order and manufacturing info, or just the placement of the different equipment in relation to each other. Typically, the more aligned and coordinated the project is in the design phase, the easier the fabrication process will also be. However, in many cases, the design process of these different industries is scattered, and the different stages do not always communicate well with each other. As projects involve components and designs from several industry areas, it can be difficult to gather all important information in one place. Often, several products are used, or even needed, to fulfill all the requirements of the project. For example, one might focus mainly on the metadata and the architectural aspects of the building, but sacrifice some precision and data needed in the mechanical designs. Or vice versa, the mechanical precision is the focus, while building elements cannot be read, or the mechanical tool is not configured to work well with this information. With BricsCAD, all our files use the DWG file format, meaning that files created with our BIM workspace can also be opened with the mechanical workspace. And the files can be combined for a full view of what it takes to create the design, so designs in context of buildings. With BricsCAD Mechanical, you can also get access to our powerful BOM manager tool, which retrieves metadata from parts of your assemblies so that you can easily prepare for manufacturing by adding a bill of materials. In this session, we will walk through a typical fabrication preparation scenario, where an in-house engineering company has designed equipment in the context of a building. The assembly will contain standard parts, custom parts, and BIM elements. So it is important for the inventory division to know what parts are needed to be ordered, both for manufacturing and to order the items, as well as finding the volume values for the building. So with that, let us get into BricsCAD and start with this scenario. At this point in the design process, we have the building, and now we have asked the contractor to help us outfit it with the appropriate equipment. Here we can see one of the garage rooms, which contains the current design for folding the electrical components related to the solar panels and car chargers. It is mostly complete with components needed, but there is one last piece missing before we can prepare the documentation for this room. The engineering department has defined a specific electrical cabinet that we have downloaded from the manufacturer. The electrical cabinet is saved as a Revit file, but with BricsCAD, we will have no problems including it in our design. With the communicator for BricsCAD installed, we can simply use the import tool within BricsCAD, select the part we want to import, and here it is within BricsCAD, ready for us to use in our design. As you can see, this equipment that comes from a manufacturer's online catalog in Autodesk's Revit RFA file format. Now, our adoption of the ODA SDK makes the process of using this part for our design incredibly easy. Now we have the accurate part created by the manufacturer, so we know if it will fit with the rest of the equipment once we insert it. But first, we can make sure all relevant metadata is available for us, so that when we generate the documentation for fabricating design, we can retrieve this information. We will make sure we have the order info, such as manufacturer name, part name, and part number. We can also toggle a value for whether it is in stock or not. That way we can set it to no, so that it is clear that it still needs to be ordered. Now that we have this info, we can go back to our assembly design and insert it. As you can see, it fits with the rest of the components. No more adjustments are required, and we can start preparing the fabrication documentation. Here we see the BOM Manager panel, where we can retrieve all information from our models within this assembly. In V23, you are no longer limited to just reading the mechanical information through the BOM Manager. You can now also create a bill of materials based on the solids and elements of buildings, or 3D solids in general. As you can see, we can create a table to find the ply volume for all the walls of the building. We can also name the table accordingly to reflect that this is the information on the net volume for the building plies. There is also some piping in the electrical room. This piping is here to contain the cables between the various components. So in the very same file, we can now create a new bill of materials table for all the pipes. We can get a list counting all piping elements to be ordered. We can also generate a cut list as seen here, so that we know what lengths and size of pipe to order for the straight segments. Once we have done this and have this information, we can save it for later, and we can also export this information so that we can have it easily accessible for ordering. Lastly, we also need an overview of all these parts to order within the electrical room. So still, we can create an additional table to retrieve this necessary information. We have also a prepared model with only the necessary information for this room for the documentation purposes. Now that we have defined the site and the equipment, it is time to make the production drawing. We can make then the table to reflect all the order information for each of the components. We can then create the layout for the drawing with all relevant drawing views and projections. We can add information on the dimensions for placement so that the installation process will be easy. And we are able to implement some tolerances as well with the power dimensioning feature. And we can apply some geometrical tolerances as well. Now we have a good view layout and important dimensions to place the equipment. However, we need the information for each part of on the drawing to be linked to the bill of materials. So we can use the bill of materials now and the balloons feature. These balloons we can place manually for each component, but we can also use the auto balloon feature so that we can automatically select the drawing view with the relevant parts. Then we can draw a polyline to place all balloons for each and every single equipment on this line, ensuring that all parts are linked to the bill of materials, where you will find the necessary information to order the part. Finally, we can make sure that the drawing settings are correct and we can print, plot, or export a drawing so that it is ready to be used for the installation process of this room. So, as you have just seen, BricsCAD Mechanical allows you flexibility in your designs with the shared native DWG file format. You can work easily with BIM files and mechanical files as a result, ensuring that design works together and is aligned for the fabrication process. In addition to this, with the new improvements to the BOM manager, you can generate a bill of materials to include all information needed for projects, regardless whether it is mechanical or BIM information. All of this, all in one place. So if you found value in today's session on this, please consider going to our website at bricsys.com to download a full BricsCAD trial to try this for yourself today. Thank you very much for your attention.